This video you will learn how to make this cool particle effect in Blender. First we'll get the animation and the 3D model from Mixamo for free. Then we create the particle effect itself. Then after this we create a material, and in the end I will tell you how to apply this not just to armature animation but to any keyframe animation that you might already have. First go to mixamo.com and in Characters tab select this mannequin. Go to Animation tab and select whatever you like. In this video I select Run animation, but later I replace it with Dancing animation, because I think dancing shows the motion a little better. Download it and move it to the folder where you can easily find it. In Blender, go to File, Import, FBX. Find what you just downloaded. Select the armature and go into the pose mode with Control tab. There, select all of the bones. You can see that the animation just ends way too soon, but because the animation is cyclic, if we just repeat it, it will be seamless. So, to make animation repeat indefinitely, make sure all of the bones are selected, hover your cursor over the timeline and press Shift E, make cyclic. And as you can see, the animation is now repeating. Now, when you import the character with the armatures, the scale is often wrong. Usually it doesn't affect the visuals, but for this one, the correct scale is very important, because a lot of math in geometry nodes relies on scale. So we do need to fix it. One fix I found is this. Select the skeleton and press Alt-S to show its true size. We see that it's 100 times bigger than it should be. Tab to go into edit mode. Shift A to add a bone. Scale it up as you like, just so it's visible. Now in pose mode you need to find the bone that the whole skeleton is attached to. When you move that bone, the whole skeleton moves with it. Once you found it, go to edit mode and select that bone. Then, while holding shift, you select the bone that we just added. Ctrl P, keep offset. After this you can go into the pose mode by pressing Ctrl Tab, and with that new bone selected, press S 0.01 to make it 100 times smaller. Now in object mode we can see that our character has correct size and the scale of the skeleton is 1, so all of the math in geometry nodes will be correctly scaled. We can hide the armature so it doesn't get in the way. Open the geometry nodes editor, select our character, add simulation zone. This is where most of the magic is going to be happening. In there, add join geometry and connect the distribute points on faces like you see in the video. Add set position node. As you can see, we set offset to be 0.2 on y-axis, and we would expect the particles to go in the positive y direction, but they are going up. It's because the character is made for different software, where z-axis doesn't mean up. To fix it, go to pose mode, select the bone that we added, and rotate it on x-axis like you see in the video. And then in object mode, rotate armature object so it stands upright again. The result looks exactly the same as what we had before, but now XYZ axes are exactly like we expect them to be, and the particles are moving in predictable ways, on Y-axis by 0.2 each frame. If you look closely, you can actually see that the particles are spawning in those weird lines. It might be the look that you like, so keep it as it is if you want. It looks like that because distribute points on faces, each frame distributes points on the mesh, but each frame it is exactly the same. To fix it, just add scene time node and connect frame into seed input on distribute points on faces node. That way each frame the distribution of points will be random, giving us more organic results. Add join geometry node at the very end. Connect the original input and the simulation zone output into it, so we can join the particles with the original character geometry. Increase the density as much as you want, but be careful, the simulation does get more heavy each passing frame. To visualize the particles a little, add instance on points node and into instance connect icosphere with 3 subdivisions and 0.01 meter radius. Into scale, connect random value node. Set mean value to 0.01 so that there is some variety to particle size. As you can see, all the particles that are created are just staying there, which makes the simulation heavier with each frame, because each frame Blender has to keep track of more and more particles. Here I didn't like the running, so I imported another animation and did all of the fixes with the skeleton and selected the same geometry node setup that we just created. If we remove the offset from the position node, we see that the particles just stay there indefinitely. Add another set position node, noise texture, uncheck the normalize, connect color into scale node to control the strength of the effect, and make it very small, like 0.1. Make noise 4D and connect scene time, seconds, into W. divide it by 4 so that noise doesn't change too fast. Now let's make it so that particles get deleted once they reach a certain age. Add store named attribute node, add named attribute. Make it integer, name it age. Math node, add 1. In store named attribute node, make sure that the data type is set to integer and the name is written exactly the same as in the other node. Connect the math node output into the value input. When the particle is born, it has its attribute set to 0 by default, and each frame it exists, we add 1 to the age attribute. Now, inside of the simulation zone, add delete geometry node. Named attribute age greater than 25, connected into delete geometry. And as you can see, all of the particles that are older than 25 frames are getting deleted. Probably give it 75 frames or more, it's up to you. Another problem is that the particles just appear when they are created and instantly disappear once they reach a certain age. We want them to appear and disappear a little more gradually. Particle is small at the start, reaches its full size, stays at that size for a bit, and then gets smaller and smaller before getting deleted. We take age attribute, connect it to map range node. If we set the values to be from min 0, from max 20, then the particle starts at the size of 0 and by the frame 20 it reaches the size of 1. Now for the shrinking, another map range node, we see that the lifetime we set is 75 frames, so let's say from min 55, from max 75. And in the end switch it to min 1, to max 0. The map range node takes the input of the values we have, and everything that was smaller than 55 becomes 1, and everything that was bigger than 75 becomes 0. And in between 55 and 75 it is a smooth transition. Get the minimum value of those two map range nodes and connect it into scale. To make the character a little more visible, we can move particles back just a little bit in that set position node. And as you can see, now all particles are not just getting deleted, but they start off small, slowly grow, and then shrink before disappearing. Now, all of the particles are the same size, so we just add random value node between a very small value and 1, and multiply the minimum output by that random value. Now it looks a lot more organic. Let's get to materials. With our main mesh selected, we can see that it already has a material, just rename it to something more readable. And for particles, add particle material and set material node in geometry nodes. And set it to particles to apply that material to all of the instances. Also add set shade smooth so that shading doesn't look flat. Now in shader editor, make the background completely dark. Select the body material. Go to object shader editor and delete everything except for the output node and the principal BSDF. Make it less rough. Now go to particles material, add emission, and it already is looking pretty nice. Add a plane and make it bigger. Make floor material into a smooth metallic surface so it reflects everything nicely. Set up the camera as you like. Make the resolution 1080 by 1920. And in the camera settings, make clip start value smaller so that the camera doesn't cut off the objects that are getting too close. We can actually access the attributes from the geometry nodes in the material. For this to work, add attribute node, type age, and switch the attribute type to instancer. It will give us data on the value of this attribute on each of the instances. We can preview it using a map range node. Adjust the values like you see in the video and connect it into strength input. Now we want to get some random values, but object info node only gives us one set of random values, where it gives each instance random value between 0 and 1. If we connect it to hue, saturation and value, the randomness doesn't work very well, because we apply the same random values into all of the three inputs. To get more random values, add a white noise node. Switch it to 1Z and before connection, add a math node. That added value will basically be our random seed value, and with 3 different seed values we'll get 3 completely different random outputs in the white noise nodes. Connect those into hue, saturation and value and connect it into emission. Now, the hue value is basically showing us the rotation out of the 360 degrees on the color wheel, where 0 is 0 and 1 is 360 degrees, that gets us into the same position as 0. We want to kind of trap the values so that the hue of the color is in between around here and here. So it's approximately between 0.5 and 0.65. So we add map range node and input those values. And change the color to have a 0.5 hue. You can do the same thing with the saturation and value, copy the values that I input or experiment as you like. Now let's make the particles slightly transparent. Add transparent BSDF, mix shader and layer weight node. If we use facing output and the value of 0.8, we get that nice transition into transparency that almost looks like a blur. this is what we get when we render it. It's cool, but I'd like to add some motion blur. 5 frames worth of motion blur, and this is what we're gonna get now. As we can see, the particles are nice and blurry, smoothed out, but the character is also really blurry, because it's 5 frames of exposure. And this is what we're going to get in just a minute. So we basically make it so that the character doesn't make any motion blur. To do that, we're gonna have to copy, Shift-D, with our character selected. And on that copy, we go into geometry nodes, into modifiers tab, and just delete it. So that this character doesn't have any geometry nodes, it's just a character. And also on our original, here in geometry nodes, we go here and we don't use that, so that this only outputs particles, not particles and the character, so just the particles. And the character is separate, but it gives us the same animation, same dynamics, same everything. And now in the object with the character selected, we go into object and turn off the motion blur and render it. And with motion blur set to center of frame 5 frames, we get this crazy effect where the character is fully in focus, fully sharp, with no motion blur, and the particles are with motion blur, which is what we want. Now, let's say that you have all of this set up. Here is the full view if you want to copy it exactly. And it looks pretty nice, but when you move it, the particles don't stay behind, they just follow us. It's because all of this math, all of this simulation, set position, is relative to the origin point of the object. And the origin point moves when we move the object. So the math moves with it. To fix it, I'm gonna use the trick I learned from Cartesian Caramel. Transform geometry, matrix, invert matrix. Object, info, self object. Gonna invert the matrix and put this like in the matrix mode, and put another one in the back, but connect inverted there. And now you can see that we can move the object around, and the particles are being left behind. So the simulation is happening in the world coordinates, not in the object coordinates.